Alright, welcome back everyone. My name is Dustin. In this video, we're going to add loading, music, and sound from memory. We're going to need to be able to do this because when we package the games, we're also going to be packaging the assets. So rather than packaging the PNG files, music, and sound effects directly, we're going to want to strip out the data and package them as compiled Lua. You can save it as other stuff as well, but that's what we're going to do. So the first thing we're going to want to do is to create a little helper function that will help us detect the audio format when we load music. So over here, we'll do it right under get music here, and we'll say mix stick type. Now this is from SDL, which is just an enum, which has the different music types. And then we can just say detect audio format. And it's going to take in a const unsigned pointer audio data and the size of the data. Size T, and we just say data size. So what this is going to do is it's going to detect the audio format of an in-memory buffer. And that's how we're going to deal with our music and our sounds. And this will inspect the magic bytes of the provided buffer to determine if it contains a known audio format. Magic bytes are the signature of the data used to identify or verify the content of a file. And let's also declare the create music from memory function and the create sound effects from memory function. So we'll just do that right here. And we can say bool add music from memory. And it's going to take the string just like this one, but it's not going to take a file path anymore. We've done stuff from memory before, just like up here with the shader from memory. We're going to want to take a either const char or const unsigned char, and that's what we're going to take here. So it's going to be const unsigned char pointer, and this will just be our music data. Then we also need the data size as well. Data size. Oh, that should be bool, not boo. Halloween. So we can copy this, and actually we might as well do it for the sound effects as well. Down here, paste that in, add sound effects from memory, and this will be sound effects name, sound effects data. And we might as well add these briefs in here. Let's copy this, paste, and we'll make some changes. That can stay. That can stay. This will be different. Change this. That is a const r pointer to the sound ram size t, the size of the sound effects passed in or sent in. Sent in is better. Cool. And let's copy this. Go up to the function. Might as well add that there. Check to see if the music exists. If not, creates and loads the. And then we have our detect audio format. Let's give it a little brief as well. Brief text audio on in memory data buffer. And the first one would be the audio data. Let's just do audio data. That is the pointer beginning of the audio data memory. Param data size of audio data buffer bytes on enum representing audio format. E wave or music MP3 og, etc. Cool. So let's actually create these. So we'll do this one. Let's actually change this to debug. And we'll try creating this now. There we go. All right. Okay, so this function needs to detect the audio format. So the first thing we need to do is check to see if the data pointer is null or if the size is too small to contain any known header. Okay, so we want to go if audio data, and that's going to be not, or data size is less than 12. Then we can leave. We're going to say scion error failed to detect audio at data size or data or size is invalid. Cool. And then we can just return music done. So there's no format. Now the first thing we're going to do is the wave format. Wave styles start with the riff or RIFF and contain wave at byte offset 8. So we need to just check that. We go if std compare audio data riff 0 and std compare audio data plus 8 wave 0. What this is doing is it's starting from the 0 point here. So it's starting from the first part of, or the beginning of the array and checking the first 4 and making sure that it says rift. And it's making sure that it's equal to 0. And that means yes. And then it also shifts it over 8 and checks to see if it has wave. Okay. And that will be determined if it's a wave file or not. Okay. So if both signatures match, then the format is a wave file. So then we want to go return, use wave. Now we want to check the MP3 format. So MP3, and MP3 files start with either ID3, the ID3 tag, or 0xFF followed by a byte with bits 111. So we're going to want to go if std compare audio data ID3. So we're comparing the first 3 bytes, or audio data first element. So what this is doing is it's just checking if those bits are set. Okay. So is this byte, does this byte have these bits set? Okay. So the ID3 indicates an ID3 meta block, which is common in MP3 files, and the 0xFF followed by 0xe0 mask is the MPEG sync word. Okay. Either of those are valid. We can return MP3. Return music MP3. Now we want to do the OGG format or OGG. OGG format. And OGG files begin with the signature OGGS or OGGs if std and compare audio data is OGGS like that. And we're comparing 4. And then we can return, use, and then we can do the FLAC format if you have a FLAC file. FLAC format. And FLAC files begin with the string FLAC. It's like this. If std copy or main compare, sorry, audio data FLAC 0. So we go return, use FLAC. And the last one that we're going to handle is going to be the opus format. And the opus files stored in OGG containers often have the opus head at byte 28. So that's what we want to check. So we want to go if data size is greater and equal to 36, because this is at 28 plus 8. Okay, so we need to shift it over. So if it's equal greater than 36 and std compare of the audio data plus 28, then we can say opus head like that, and then this is 8 0. And if those are valid, we can return opus. Return, use. Otherwise, we're going to have a small error here. Let's say scion error failed to detect audio type unknown or unsupported format. And we can return music none here. Use none. Awesome. And that's it. That's all we need for comparing our data here, or detecting our audio format. That's perfect. So now we actually want to do add music from memory function right here. Cool. Okay. So just like adding other music, we're going to need this here. So we want to check to see if it contains the music file. If it already contains it, then we can just leave. Okay, so and we can say false here. Cool. So if it contains the music of the music name passed in, fail to add it because it does already exist. Okay. So this one is going to be a little bit different. We're going to need to use SDL read write from mem function. Okay. And that will take in the data. And that returns an SDL RWAPS. SDL RWAPS is SDL's way of abstracting data sources, allowing the same APIs to work with files, memory, or custom IO. So this will allow us to actually use the embedded memory rather than having to constantly read from a file. So that's what we can use. So we want to go SDL RWAPS pointer and RWAPS equal to SDL right from mem. And this takes in a void pointer to the memory and the size. So we can go either a ccast void pointer, or you can do a reinterpret cast here. That's the music data. Then we want to go static cast to an int the data size. That will give us the RWAPS pointer that we need. Then we're also going to want to detect the music type. So we want to go mix music type equal to detect audio format. That's the function we just made, and that's our music data, and data size. Cool. We want to check to see if it's a valid type. So if type equal to mus none, we're going to want to leave scion error failed to add music from memory, unable to determine type. Awesome. And then we can just return false here. So now we want to load the music from the mixer, from STL mixer. And from that, we need to go auto music equal to mix load use type read write. So we can go RW, that takes in RWAPs. As you can see, it takes in RWAPs and it takes in the music type. Then it asks if you want to free the RWAPs once you're done. And yes, I do. So it takes in the RW or the RWAPs, and then it takes in the type, and then it takes in. So right here, let's do that again. You see, so free source non-zero close to close free the STL RWAPs before returning, 0 to leave it open. And we want to close it. We don't care about it because we're going to hold on to this. We're not going to get rid of the music data. That'll always be existing. Because when you're using music, music is streamed. So you need to keep the data alive at all times. You can't just get rid of the data. So once we have the music, we can go if not p music, make sure it's valid, and Scion error failed to load or failed to add music name. Name turn false. All right. Otherwise, we need to create our sound parameters. And I believe we do this up here already. We don't need to do the in place back stuff here because it's not a file. So it shouldn't change. So we can grab all of this, create the sound parameters. Let's grab that. Bring this down here, paste it in. And it's not a file path. I'm just going to say from data here. From data. And the duration can stay the same. The name, yep. Params, all the same. Cool. Otherwise, return this success. Awesome. So that should be work for our music. So all we're doing here is we're checking to see if it contains the music. If not, we're getting a pointer to RWAPs, detecting the audio format. If the format is not none, and then we want to load the music type from RWAPs. Okay. And these are all functions that are already given to us by SDL. SDL is great in that sense. A lot of the work is already done for us, which makes things a lot easier. So we're kind of standing on the shoulders of giants in reality. So we get our music and then just do it like we did before. Create our sound parameters and do all this stuff here. Create our music pointer and place it into our map. Pretty straightforward, right? Cool. All right, so let's go to the add sound effects from memory function. And this one's pretty similar. We can actually copy this here, paste that in, because that's going to be correct there. And we want to do the same thing. We want to load from RWAPs. Okay, so that's just SDL RWAPs pointer SDL a void pointer of the sound FX data, and then the static cast of int of the data size. Then we want to get the audio chunk or the mix chunk. So we want to go auto p chunk equal to mix load wave RW. That takes in the RWAPs, RW, and we want to free. Then we check to see if not p chunk. Then we want to do an error, Scion error. Failed to add sound FX from memory. Turn false. That's really it. It's basically done. Now we just have to do the sound params. And that's just like this here. We can copy all of this. We've already done. Copy that. And bring that down here. Paste it in. We have to change this to from data, control KD, then return 6. So all we're doing here is creating our sound params and then loading it into our map or adding it to our map. Okay. Create a sound function pointer from the chunk. This is just a wrapper around the chunk so we can destroy it once we're done with it. And that is it. We could test it, but I don't have any sounds ready. So let's actually just do a build to make sure it's all working. Awesome. So no errors. That's great. So we actually want to test this out. So let's actually close this and let's go to OpenGameArt and download some music. So just music, and I want CCO, just anything really. I'm just gonna get this Field of Dreams by Poly Polyuw. Grab that. Cool, we got that. So I want to just go to folder. And I got this here, Field of Dreams MP3, right? So what I need to do now is we got to make this into memory. So what I already have is I have my binary converter that I created before. So it's just a simple program that will help me change the files into binary. So just open this and I want to get that out of the way. And I can just drag this file into here. Cool. So that's where it is. And I want to create a C style table size, and then I want to just call this uh thick, right? Because I'm not going to keep this. I'm just using it for testing. So it's going to be that, and then I want to set the out file right here, and I'm just going to call this music.h, where it's going to go, and then I'm just going to generate. Oh, so it generated it for us. So I should be able to go here. We have our music.h. If I open, it's just a table. Massive table, but it's a table nonetheless. So let's grab all of this, Control A, Control C, go into our program here, and we're just going to add some temp data somewhere. Now, we can do that right in our core, and already doing that with fonts or, oh wait, let's go to our editor. So right here in our editor, sound editor, editor, down here, utilities, not fonts, editor textures. I'll just put it here in editor textures because I'm going to remove it, right? Now these are just pointers or to the data, but we're just going to paste this in here. Okay, it didn't like that. We're formatting because it's too big. 100,000. So that is a huge file. So you're probably not going to want to use that one, but I'm just going to use it anyway because we already did it. Oh, just go right up to the top. That file is massive and it's called music. I'm going to change this to music data. Copy that, go to the bottom. Data size. I got to turn formatting on. Music data size. Cool. And let's actually try to load this. What's the worst that could happen, eh? So we have our editor textures and we can just save this file. Let's go right into the asset manager here and go up to the top. And this should already have, no, it does not have the editor texture. So let's go to our application.cpp here. And I think we have load editor textures. Yeah, let's go to this function and go right to the bottom here. And I want to go asset manager dot add, and that takes in, we'll just call this big or I can say data and data. If not, we're fail to add. Sure, we're going to take this out anyway. So, okay, these should work. And let's run it. Okay, so music data is undeclared. Sense because it's probably fine. We're going to Oh, it's not liking that. Go back to here. I this real thing. Take We want to copy. Go here. Copy this. Bottom. Copy this style. Copy our audio, music data, and music data size. Basically, I want to do the same. Bottom. Get rid of the extern. Then we have to go back to here. Those changed to E music size. So go back into our application. This. Awesome. So that worked. So we're loading the project now. Let's actually create a new project. So this should be on any project. So let's project, and it can be anywhere really. And then we'll just call this tester one. Create project. We'll create our music. Bang, music one was loaded. That's exactly what we want to see. Now we want to test to see if it works. So let's actually create a simple scene. Add scene. Scene one. Okay. Cool. So we have our scene one. Let's load it into map editor. Let's actually just save it. Now we probably don't want to save the music, so we're not going to actually save it because we wouldn't really want to load music from memory in the editor unless it's an editor music, right? So for memory is for when we actually create the runtime. We don't really need it right now. When you're still in the editor, you can do everything from files. Okay. Now I just want to test it. And the way we test it is we go to scripts. Let's open up our main Lua right here. This is new. Okay. And right here, we can just go music.play and we called it music. So that's our music. That down and let's run the scene. It should play that song for us. Let's see what happens. Oh, we got an error. Error. Oh, yes. It's got no script list table created, right? Right here. So it does have the script list, but it's got no table, and that's fine. Clear that. And just for funsies, go back here and in our scripts, create a new little object, little file, Esther1. Oh, so we created that, added that, generate that, and go back to our scene and play. There's our music. Awesome. So it's working exactly how we wanted it to. It loads the music, loads it into our assets, and works exactly how we thought it would. Now, we wouldn't want to use that music file because it's a massive file, but it's still working. So it's doing the job that we wanted to do. And that's it for this video. Please like and subscribe if you haven't done so already. If you have any comments, questions, or concerns, please let me know and I will make sure to get back to that. We also have a Discord channel. You can get over there and ask questions on there, go back and forth. If you're having problems, it's probably easier to answer these questions on Discord. Yeah, so make sure you check that out. Check out the GitHub repo and give it a star if you want. No, check out the GitHub repo because there's going to be different changes and stuff that come along the way that I might not make a video for. And that's it for this video. And we're going to continue with the packager and all that in the next video. Okay, take it easy.